Okay, so now we're ready to graph these big guys. These are all nice and factored for us, so we can easily see where the intercepts are. So here I have an intercept, a -3 will make that 0. Also we have an intercept at -1 and an intercept at 2. Now what I like to do when I graph these, and other people do it differently, I like to mark the multiplicity by each 0. So this guy here had a multiplicity of 2, this guy here has a multiplicity of 3, this guy here had a multiplicity of 5. And that's going to tell me the behavior of the graph at each one of those points. Because this has a multiplicity of 2, it's going to look like a little miniature parabola when it touches that, that intercept. This is going to look like a little noodle. This is going to be a slightly flatter noodle. So hopefully that'll make sense when I draw it. I want to determine the end behavior, so I want to see if this is an even degree or odd degree polynomial. So if I were to multiply this entire thing out, the degree would end up being 2 plus 3 plus 5. So 2 plus 3 plus 5 is 8, 9, 10. And that's even. And we know that even degree polynomials have end behavior that's the same. It's an up and up because it's positive. So instead of down and down. So, ready to graph. I know I'm going to start up here. I'm going to start up. I'm going to go la-da-da-da-da-da-da. When I hit this one, it's going to look like a little parabola. When I hit this one, it's going to look like a little noodle. When I hit this one, it's going to look like a slightly flatter noodle. And back on up. So notice it doesn't have to be, the positive negative thing doesn't really come into play because this noodle was upside down. Doesn't matter. It's just like when you hit here, you kind of bounce up to look like a parabola. When you get to the third, you know it's going to cross through just slightly flat. When you hit here, it's going to cross through just slightly flatter. We ended up, which is good because we knew we were supposed to be on the up and up, and so that's happy. We're going to try the same thing with the next one. Hopefully it will make sense. You just have to see a bunch of these practice ones. So this one, we have an intercept at -4 with a multiplicity of 2, a -1 with a multiplicity of 1, right? And let's make this negative just so they're in order. So a +2 with a multiplicity of 4. Oh, yeah, that's right. So here, if I were to find the degree, if I were to multiply this whole thing out, it would be 2 plus 1 plus 4 is 7, which is odd. So I know it's a noodle-shaped graph, and because it's negative, it's going to go down. So I'm going to start up and start to draw. So start up. When I hit the multiplicity 2, I look like a little parabola. I bounce up. When I hit the 1, I'm going to cross straight through like a line. When I hit the 4, I'm going to look like a little parabola, bounce down, slightly flat there. So these are like really ridiculously rough sketches, right? They're just describing end behavior and the behavior at each of the intercepts. If I wanted to make them more exact, I would, plug in some points between, see how high those go. Right now, it's very imprecise, but it does kind of give you a nice sketch, an idea of what the gist of the graph